Hello everyone. Till now, so you have learnt about DC circuits. So now we shall move on to the next chapter, which comes under the same module, that is module 1, that is AC fundamentals. Okay. So before move on to the AC circuits, you need to learn some of the fundamentals in AC. AC circuit consists of alternating voltage source. Okay, so remember, AC circuit consists of alternating voltage source where the alternating current passes through the circuit elements like resistor, capacitor and inductor. Okay, so right, AC circuit consists of alternating voltage. So alternating voltage, so we represent in this form. Okay, so here where the alternating current passes through the circuit elements like resistor, inductor and capacitor. Okay, so not necessary to have all the three components here. Okay, passive components. So it can have only resistor, or it can have only inductor, it can have only capacitor, and or sometimes it can have the combination of R and L, combination of R, C, and of course the combination of RLC. So this is nothing but AC circuit. Okay, in this AC circuit you can see alternating quantity, because this AC stands for alternating current. So here we see alternating voltage and alternating current. So that means alternating quantity. So alternating current or alternating voltage, right? So the magnitude changes with respect to time. So that means it can have only two directions, that is positive and negative. So here the magnitude of the voltage or current. So here this we can consider as either voltage or current, that is alternating current or alternating voltage. Here the magnitude of the voltage or current changes with respect to time. With respect to time, and it can have only two directions. One is positive, so this is positive direction, and this is negative direction. So this alternating quantity may have any shape. So it may have triangular waveform, and so it can have so this rectangular waveform and or the sinusoidal waveform. Okay, but so in electrical circuit, okay, in electrical circuit the alternating voltage or alternating current are in the form of sinusoidal quantity. Okay, sinusoidal waveform. So why the sinusoidal waveform is preferable? So here the successive derivative or integral of the sinusoidal function is again sinusoidal in nature. Okay, that is the one reason we prefer sinusoidal, and of course the mathematical analysis would be easier, right? And the current through the capacitor or current through the inductor, okay, if we consider the current, the alternating current through the capacitor or alternating current through the capacitor, and if we find the voltage across the capacitor or voltage across the inductor, we get again sinusoidal function. So this is why we prefer sinusoidal function to represent alternating current and alternating voltage. So these are the advantages of considering sinusoidal function. Okay, next I will be explaining you about generation of an alternating quantity. Okay, so now in this particular chapter, so you will be learning about the fundamentals of AC. Okay, and once you learn the concepts of AC, then you will be understanding in the next chapter, in the next module, you will be understanding AC circuits better. Okay, and before that, so you need to understand the generation of alternating quantity. So how alternating quantity can be generated? So that is with the help of Faraday's law. Okay, I hope you have already learnt about Faraday's law. So this Faraday's law, so what exactly the Faraday's law tells us? So here the EMF will be induced whenever there is a change in flux happens, right? So EMF will be induced when there is a change in flux happens, that is with respect to time. So that is Faraday's law. And so you can see in this figure, so in this figure, okay, now let us call this as figure A and this is figure B. Okay, so in this figure you can see two magnetic poles, north and south, and so here the conductor is placed, or we can also call it as coil. So conductor is placed between two poles, magnetic poles, and this dotted line is indicating magnetic lines of force, or we also call it as magnetic flux. Okay, so here initially in this position, that is in figure A, so let it be in this position, so it is kept constant, so it is not moving. And so now if I consider the next figure, so here the conductor, okay, now conductor is rotating. As the coil rotates, okay, as the coil rotates and with this angular velocity omega, as the coil rotates with angular velocity omega, so the flux linking with it, okay, the magnetic flux linking with it changes, and hence EMF will be induced. That is according to Faraday's law. So there will be change in flux, okay, EMF will be induced when there is a change in flux happens. So here in this position you can see as the coil rotates with the angular velocity of this omega, the flux linking with it changes, and hence EMF will be induced. Okay, and so the same part is demonstrated in this figure, right? So here the maximum flux, okay, the maximum flux linking can be resolved, okay, into two components. One is phi m sin omega t and another one is phi m cos omega t. Okay, so considering this as the conductor and with the angle theta, so it now it has been rotated with the angle theta, and this part can be, so as I have already told you, so the maximum flux linking with it can be so resolved into two components. One is phi m cos theta, and where theta is equal to omega t. Okay, so where theta is equal to omega t, so phi m cos theta and phi m sin theta. Okay, but so finally here since we find this theta, so that is with respect to the cos, so therefore the flux linkage that induces an EMF is phi m cos omega t. Okay, so even though it can be resolved, the maximum flux can be resolved with or can be resolved into two components, but finally so the flux linkage that induces an EMF is phi m cos omega t. Okay, and okay, why we don't consider phi m sin omega t? The component phi omega t which is parallel to the magnetic flux, that is, so when it is at this position, so it will be parallel to the magnetic flux, so EMF will not be induced, right? So when the component sin omega t is parallel to the magnetic flux, EMF will not be induced. So, and this phi m cos omega t component, that is perpendicular to the magnetic flux, when it is perpendicular to the magnetic flux, so EMF will be induced. So because of that reason here, so the flux linkage that induces an EMF is phi m cos omega t. So now based on this statement, therefore the flux linkage that induces an EMF is phi m cos omega t. So remember this omega t, where omega t is equal to theta. Okay, and now according to Faraday's law, so induced EMF, that is E of t, is equal to, so n into, that is minus n into d phi by dt. So as I've already explained you about this EMF will be induced when there is a change in flux with respect to time. So when there is a change in flux with respect to time, or we consider induced EMF, okay, is directly proportional to the change in flux with respect to time. So the proportionality is replaced by n, which is the number of turns. So minus n into d phi by dt. So now we are going to substitute, because we have got that phi is equal to phi m. Since we consider phi m cos omega t as phi, so we get phi is equal to phi m cos omega t. So now we need to substitute this equation in this Faraday's law equation, which is minus n into, so we need to differentiate this, we need to differentiate the term phi m phi m cos omega t with respect to time. Now in the next step we have so minus n, and of course phi m is constant, you can take out of the integral, and so we are differentiating cos omega t with respect to t. And in the next part we get minus n phi m omega into sine minus sine omega t. So we get minus n phi m omega into minus sine omega t. So we have minus and minus, and next step we can write E of t is equal to, it is plus, so n into phi m omega. So in the next step, so we get E of t is equal to n phi m omega sine omega t. Okay, so now I am going to replace this omega t as theta. So we get E of t is equal to n phi m omega sine theta, right? So here, okay, when we get the maximum value, so we get maximum value when theta becomes 90 degree. So we get the maximum voltage or the maximum component when theta is equal to 90 degree. Okay, and this becomes n phi m omega. Now let us call this equation as 1 and call this equation as 2. Right? So now I am going to substitute equation 2 in equation 1. So we get E of t as Em sine theta. Okay, so this is the last expression of alternating quantity. Okay, so now based on this equation, so we will see how the alternating quantity can be generated. Okay, so when theta is equal to 0, so we have to substitute the values of theta here, and before that you need to label it. So like now we have 0 here, and this is, let us consider this as pi by 2, and so pi, 3 pi by 2, and next is 2 pi. Okay, and so if we substitute initially theta as 0, so theta is 0, so we get E of t as 0. Okay, and in the y axis let us have this as E of t. When theta is 0, it is again 0. And what is the next value? That is pi by 2. When theta is equal to 90 degree, so we get E of t as Em. So E of t as Em, and let us consider this as plus Em, and this is minus Em. So we get till this point the maximum voltage. And so when theta is equal to pi, that is 180 degree, so here we get again 0, and when theta is equal to 3 pi by 2, so substitute 3 pi by 2 value, that is 270 degrees, so we get the minus value here, that is minus Em. So if we substitute theta as 3 pi by 2, so we get E of t as minus Em. So we get minus Em here. Next value, if we substitute theta as 2 pi, that is 360 degree, so we get again 0. Okay, so this is how the alternating quantity can be generated. And here, so we have many terms here. So this we call it as, when it completes one full cycle, so this we call it as, okay, that is with the duration of t. T is the time taken to complete one full cycle. And similarly we also define f, which is the frequency and which is the reciprocal of time. Frequency, which is the reciprocal of time. So how do we define frequency? It is number of cycles per second. So frequency is defined as number of cycles per second, and the unit is hertz. Okay. Now let's see one example based on this alternating quantity, and what are the parameters comes here to find. Okay, so remember here we have the peak value, and of course we also call it as the amplitude and frequency, then time, right? Okay, so in this example you can see this is the given expression. So given expression is E is equal to 200 sine 314t. Okay, so look at the expression. This is alternating quantity expression, and this is nothing but instantaneous EMF. So whenever we express this equation in terms of small e, we call it as instantaneous EMF. So similarly, same type of expression can be expressed in the form of instantaneous current, that is in small I. Okay, letter small I. So in this expression, so now you can just compare this expression with the equation which we have derived in the previous topic, that is in alternating quantity. So E is equal to Em sine omega t. Okay, and remember in the expression what I have derived in the previous topic as Em sine theta. So theta is equal to omega t. So now when we equate these two expressions, then so the first part is we need to find out these three values in the first part. So we need to find out the value of amplitude. So which is amplitude here? So remember this value, so Em is equal to amplitude, and we call it as the maximum voltage and the peak value. Okay, so this is nothing but amplitude. So anything can be considered. So this amplitude, peak value and the maximum voltage all are same. So here in the first, amplitude is nothing but Em. So straight away you can write Em is equal to 200 volts. Okay, now so in the second part, so we need to find out the value of frequency. So in frequency, here the frequency, how we can calculate the value of frequency? Omega is nothing but, so in the second part, so remember omega is equal to 2 pi f. Okay, this is angular velocity omega, and which can be expressed in the form of frequency as 2 pi f. So where f is equal to, how we can calculate f? F is equal to omega divided by 2 pi. And so when we just compare the standard one with the given expression, so what is omega? Omega is equal to 314 divided by 2 pi. Okay, so we get answer as 50 hertz. Remember, so hertz is the unit of frequency. Okay, so now we have calculated the value of frequency, and in the third part, the instantaneous value when t is equal to 1 by 200 seconds. So which is the instantaneous value here? So instantaneous value is this small e. So to find the value of instantaneous EMF, that is E, so we need to have the expression, the given expression E is equal to 200 sine 314t. So here we need to substitute the value of t here to calculate the instantaneous EMF or the voltage. So E is equal to 200 sine 314 into 1 by 200. Okay, and if you simplify this expression, so you get E as 200 volts. And one thing you need to be careful while simplifying this kind of expression, that is especially in the calculator, if you are calculating, so it should be kept in radians mode. Okay, remember, so whenever you are finding out the value of this E, okay, by substituting the value of t, right, so that is in terms of this sign, it should be kept in radians mode. Okay, so why it is in radians mode and why not it is in degree mode? Okay, so here this 314 which we have got here, it is in terms of, because as I have already told you, omega is equal to 2 pi f. Okay, 2 pi f, and here the value of pi is substituted as 3.14, right? So here in this equation, the pi value which is substituted as 3.14. See, you can just verify this. So if you substitute pi as 3.14 and frequency as 50 hertz, then you will be getting omega as 314. So remember, pi we have taken it as 3.14. right? So we have not taken it, it is a given value, but here the given value of course that is considering pi as 3.14. So that is why while calculating this value it should be kept in radians mode. Okay, so when it can be considered in degree mode? So when you replace this omega as omega, that means pi as 180 degree. When you replace this pi value as 180 degree, then it can be kept in degree mode and you can calculate the same. Okay, example, so E is equal to 200 sine. So now omega, so what is omega? Which is 2 into 180, because 2 pi into frequency, that is 50 into 1 by 200. See, look at this expression here. I have taken pi as 180 degree. So now you can have it in degree mode and you can calculate, you can simplify this expression. Even then you will be getting the same answer, which is 200 volts. Okay, I hope it is clear. Okay, in the next problem you can see the given expression is in the form of instantaneous current, which is I. Okay, remember this instantaneous equation can be expressed in the form of both current as well as in voltage. So I is equal to 141.4 sine 3140, and which is exactly similar to the previous problem. Just to practice, so I have taken in terms of current. So here, so you need to find out the value of maximum current. Okay, maximum value. So as I have already told you, maximum value, peak value, amplitude, so all are same. Okay, so now you can just compare this given expression to the standard value, which is I is equal to Im sine omega t. Okay, so when we derive the expression, we have expressed in terms of instantaneous voltage, which is E is equal to Em sine omega t, but here, so we can compare the same expression, that is given expression, to the standard one, which is I is equal to Im sine omega t. Now, so which is the maximum value here? The maximum value straight away you can consider Im, which is 141.4 amperes. So remember, the unit of current is amperes. And in the next value, of course, the frequency. So frequency can be considered in this form, where omega is equal to 2 pi f, and so omega is 314, which is equal to 2 pi f, and simplify this expression, so you get f as 50 hertz. And the time period, so how we can find out the time period? So take the reciprocal of frequency. So to find the value of time, t is equal to 1 by f, which is 1 by 50 hertz. So you get the value of time. And in the next part, the instantaneous value, that is instantaneous current, when t is 3 milliseconds, so which is exactly similar to the previous problem. So you are just replacing this t value as 3 milliseconds. So that means I is equal to 141.4 sine 314 into 3 into 10 power minus 3, because 3 milliseconds. And while simplifying this equation, so remember the calculator should be in radians mode, so you get the value of current. Okay, thank you.